So today we are going to start aldehyde, ketone and carboxylic acid. Since this is a revision class, you know the drill. We will basically follow question to theory approach as we were doing in the past 3 chapters, right? So now let's see how much you have gone so far. If I ask you few questions and we will try to revise the reactions accordingly, right? So my first question to you is very basic. Let's see if you are able to recall which type of I use. What do you think so? So we will start from the very basic, right? Understanding all the important reactions that are basically most likely to be asked in the exam. So what will be the product? So like you can easily identify whenever there is palladium barium sulfate in presence of H2, then you can identify it as Rosenmund. But other than that, what will be the product? What will be the product of this reaction? Hmm? Benzaldehyde. Great. Benzaldehyde. Now, question 2. Let's suppose you have an alcohol and you have, or let's suppose it is a ketone and you have aldehyde, and I want to basically make this. What set of reagent, or maybe a single set of reagent, I'm supposed to take if I want to end up with this conversion? So basically, yeah, both of any form of reducing agent here, maybe NaBH4 or LiAlH4 can solve your purpose. But suppose I want, from the given set of substrate, I want this. Now you have to be very specific. So basically it is similar. I have just rotated this bond. Now suppose I want this. Can you suggest me some method? Maybe we have discussed this method while discussing alcohol phenol ether. Maybe we have discussed this method in the year-long course. Maybe you have seen this method somewhere else in your year-long preparation. So can you remind me of a very fantastic method that we can use if I want to basically no, Subramanya, it's just been started. Whatever is written on the board is all we have done. Tell me. No, Vaishali. NaBH4 is, or zinc mercury amalgam is going to reduce your basically both the ketones. Ketones, basically if you use zinc mercury, then the ketone will be reduced to alkane hydrocarbon, right? So you cannot use ZnHg. And NaBH4 on the other end, if you used, then it will again reduce both aldehyde and ketone, because NaBH4 does not act on esters or acids, right? No, Grignard reagent will take you in a very different direction, Shreya. So it is not going to meet up your requirements. Think. The answer lies, let me give you a hint. The answer lies in the protection of ketonic group. Are you able to remember any reaction that deals with the conversion of ketone to a cyclic form of a compound, which upon hydrolysis reverts back the ketone in the presence of an alcohol, acid, something? Are you able to remember this very kind of a unique, or you can say fundamentally very important reaction. Yes, Vaishali, now you got it. So what we can do, if we want to reduce the aldehyde portion only, and we do not want to disturb ketone, then the problem with NaBH4 LiAlH4 is that they are going to reduce both of them. So the thing is that first, what we will do, the first step will be the protection of the ketone by using diol in H plus, ethylene glycol, or maybe dithiol can also be used, right? Now, what will happen if you do this? It will be first converted to this. Now, if you apply LiAlH4 or even NaBH4, what you will get is the reduction of this ketonic group, aldehyde group, because ketonic group is now protected. So it will form this. And once you get this, what you need to do is you need to basically, you can say simply use Rane nickel to reduce it back to the ketone, or you can use acidic hydrolysis sometime also. So it is common. So this is how this was done. I hope that you got this method. Yes, the method is same. Right? Understood? Now, the next question. Sorry. Uh, that could be of some use, but the problem is that, Shreya, when you will reduce COH group, probably not just your COH will be reduced, your ketone will also get reduced to a secondary alcohol. Are you able to understand what I am trying to say? I'm saying that okay, this is approach is okay, acceptable, that you use tolerance and oxidize your aldehyde to acid, but yeah, that is the issue that you might face. Otherwise, if you have a selective reducing agent that reduces only acid to primary alcohol but not the ketone, then your purpose will be solved in this preparation or in this strategy. No, Vaishali, not cyclohexanol. Cyclohexanol, in fact, will have, or maybe cyclohexanol, but you will not call it cyclohexanol. In fact, you will call it probably cyclohexyl, one cyclohexyl methanol or something, maybe. cyclohexanol भी बोल सकते हैं वैसे technically, right? Yes. So the first step is hydroboration oxidation that leads to the formation of alcohol at the less hindered carbon of the alkene, followed by the oxidation of primary alcohol. What is the role of PCC? To oxidize 1 degree alcohol to aldehyde, right? Because it is a mild oxidizing agent. So what you will get is the corresponding benzaldehyde, not benzaldehyde, the aldehyde, right? So you will get this. Got it? Now, suppose you have this. let's not use this. And on the other end, you use. So can you comment on this reaction? Try solving this reaction. Try this. THF is solvent, beta. Shreya, tetrahydrofuran. So it is acting as a solvent, basically, just basic solvent. Yes. Let's see. So, protonation of this OH group in acidic medium and followed by heating will cause elimination. So you will get this. Then when you do ozonolysis, basically, so this is your P. When you do ozonolysis, the complete ozonolysis cleaves the bond in such a way that you get two same molecules, right? So basically you get this from both the sides, CH3CHO. And once you treat this CH3CHO with CrO3H plus, since this is a strong oxidizing agent, it will probably oxidize your aldehyde to acid, right? And then corresponding acid. And then if you use on the other end a strong reducing agent like LiAlH4, what you will get is corresponding alcohol ethanol, right? So this is what you are going to get. And somehow, interestingly, if I reacted these two in, let's say, basic medium, can you comment out on the product? Suppose these two reacts in basic medium. So what I am saying, that R and S reacts together in basic or acidic, in both the medium it will be fine. Basic medium. What are you expecting as T? Very nice, Vaishali. Very nice, Manisha. So basically we know that whenever we combine an acid with an alcohol, right, especially aliphatic alcohol, what we get is an ester. Corresponding ester having formula COOCH3 CH2CH3, right? So what you will get is this. Or maybe they can ask you in a different way. Let's suppose they have given you the structure of glucose in the Fischer form. They can do this. Suppose this is alpha D, not alpha D, this is D glucose. And they react this with the, suppose HCN, right? Base, you get this. And obviously, when you get, you can write this as HCN as one equivalent, and this base also as one equivalent, right? So you get P ultimately, probably. And ultimately you hydrolyze it so as to give out the proton to any needed species, you get Q. So that is how they are going to combine the questions of two important chapters in one. By asking the name of this compound Q, this question becomes a question from biomolecules. And by asking the structure or the type of reaction or the main functional group formed or the main functional conversion that happened, this question belongs to the chapter aldehyde ketone carboxylic acid. So this is how beautifully your syllabus has been designed, right? So what you will get, we know that HCN on aldehyde forms cyanohydrin. So what you will get is this ultimately. After hydrolysis, what you will get is OHCN. And obviously there is on this carbon you have an H, right? So you can write it is like this HCN, and you have this rest part as it is OHH, HOH, OHH, OHH and CH2OH. Cool. And now tell me, if you hydrolyze this, still, if you hydrolyze this, what will you get? Suppose here you have not hydrolyzed it. In fact, you have just, this will give you this directly, right? So there's no need for hydrolysis. This is the only step. Hydrolysis की जरूरत नहीं पड़ेगी यहाँ पे. So what will you get if you hydrolyze this cyanide? So basically will be converted to acid. So this is what we need to understand, right? Right? Done? So nicely done. Now, suppose you have this. Now this is again a very important question, and we have practiced this question in the previous chapter as well. That if I want to prepare this to this, how am I supposed to do this conversion? What you are supposed to do is, you have to use first a base, that may be NaOH or KOH, and along with it you need CO2. Once you done this, you get an ionic species, a salt. If you hydrolyze this, you will get acid, right? And suppose if from the same compound I want this, then what am I supposed to do? Yeah, this reaction is known as Kolbe's reaction. The other one, you can use NaOH, KOH, doesn't matter. Any base will do theoretically. Reimer-Tiemann, nice. What is it? And in that case, if you use KOH suppose, and along with it you need to use chloroform CHCl3, second you have to hydrolyze obviously, then you get this, right? Right? So this is Reimer-Tiemann. Now tell me, now this is a question that probably we have understood many times. So be wise on this. I have told you many times the difference between this. So you have to go through this reaction. How do we consolidate the reactions to revise before exams, like any order to follow? Venkat, there is no such order. The only thing is that you should classify them in a way that you feels easy to revise for. Yeah, revise with, right? Yes, Srinidhi. Let's see. So clearly, there is no denial that treating an aniline with NaNO2HCl at 0 to 5 degrees centigrade leads to the formation of the benzene diazonium chloride. And then, following its reaction with Kc and heat, what you will get is cyanobenzene, right? And now the difference is that if you treat it first with SnCl2HCl, that is Stephen's reduction, then probably you will get imine, right? So you need to have a very clear understanding of this. And when you hydrolyze it, then you will get a aldehyde here, right? And then the other path is, if you directly hydrolyze it on the other end, what you will get, we very well know, is a benzoic acid. So very nicely differentiating the two methods leading to the two different products, right? Now you have to keep this in mind that there were two methods here and there are two methods here that are basically responsible for you to get this kind of acidic or aldehydic group. Now suppose if I, yeah, very nice, very nice. Okay, okay. So you guys have a certain preparation. I can understand this like this. Now, tell me this. If I want to convert this to this, or let it be like CH3. If I want to convert this to this, what am I supposed to do? And if I want to convert this only to this, what am I supposed to do? The next level of difficulty arises from this question. Only those who have deepest understanding of the concepts will be able to answer this. Let's see how many of you. No, you need not to go to that much basically. Just remember, if you want a mono substitution of replacing just a Cl with this CH3, not disturbing the CO group, you can use the cadmium based, cadmium based Grignard reagent. Yeah, you can say cadmium based organometallic compound in a form which will be in a form CH3 whole twice CD, right? So you have to use this particularly CH3 whole twice CD, right? And once you use this, you will get single substitution. And if you on the contrary use the R2 Mg something RMGX, means that is going to be very much reactive because cadmium is relatively covalent, more covalent, less reactive. Magnesium is highly reactive, so that is why its Grignard reagent, whatever you call it, RMGX, is very reactive. It attacks two times and ultimately leads you to the formation of the primary or secondary or tertiary alcohol, whatever, right, based on the substrate. So if you use CH3 MgBr, na, you will get this basically. Yes, obviously there are some other there are some other additives that we use. The one is dry solvent, dry ether, something like that, and in the other reaction we use hydrolysis. Here also we are going to use that similar thing, right? So you need to understand, right? Now let's see how many of you are able to solve this. Difficulty level 3. Intramolecular Cannizzaro. Very nice, Ashmit. So what you will get is the product that basically involves both the alcohol and the acid, the salt of acid. Very nice, Vaishali. You have cracked down a very minute detail in this product formation. That's nice. I can confidently say that you 34 students among which are here in the class, 34 students, I guess all of you are quite well prepared for IAT and NEST. So it is my request to you guys that please do not lose the confidence and do not lose the pace, do not lose the continuity. I can see that all the concepts are very well retained in your mind right now. So all you just need to do is keep on revising, keep on grinding, keep on practicing the questions from the relevant sources that you're getting, and that's all. Nobody is going to stop you from getting to IISc Bangalore or whatever your dream institution is, right? So understand this. Now what you will get is the disproportionated product. One will be the salt, which is going to be ultimately formed to acid, and the other one will be the alcohol, primary alcohol, right? Because both were similar, so either ways you can form anyone as LDI, anyone as acid, or anyone as alcohol. So once you hydrolyze it, your acid returns back to its original form, right? Very nice. And now remember, if somehow I use NaOH again, heat, can you tell me what is going to form now? Because I just used the same reaction moment ago. I guess 1 or 2 slides back I did similar reaction. You answered the question. Now it is your turn again to answer the same question, which is basically asked on a different principle, different type of substrate. Shouldn't it be aldehyde in the question? Oh हाँ यार, this is aldehyde. Sorry, my bad. This is aldehyde. This is what I was about to ask, and you people also should notice this, right? You should say this up, speak up. That okay, sir. If we are doing Cannizzaro, these are supposed to be not acid. These are supposed to be aldehyde, right? Very basic, right? Now tell me. Thanks, Srinidhi. Very nice. Hawkeye. Benzyl alcohol and sodium benzene. No. It array. You have base, you have an acid, you have an alcohol. अब तो बता दो. No. One acid, alcohol, base, acid, alcohol, base. Intramolecular esterification, right? So what you will get is this. Got it? Batao. So this is the last step that they may extend this year, which they have not up to now. Now let's see. This is the maximum difficulty level question that may be asked with you, asked to you, obviously. Let's see how many of you are able to, answer this. So there's a difference. Most of you might have studied this one. So if this is the case, same. Now can you tell me what will be the product? Yes, Venkat, you are right. Don't worry, you are right. So basically the first one is a simple aldol reaction. The only thing is that we have reduced the number of cross products by removing alpha hydrogen from the other species, which will act just as an electrophile now. So here you will get to the more electrophilic one, which is aldehyde, you will get the acid correspondingly, and to the less electrophilic relatively, you will get the primary alcohol. But here, this is Cannizzaro, intermolecular Cannizzaro. But this, my friend, is aldol, because this alpha hydrogen. So what is going to happen? This OH minus will immediately abstract the proton. It will form this. Okay, just write it down in the reverse way. You will get this, and this CH2 minus will attack on the carbonyl of the other species, making this something like that. And then obviously it will abstract the proton, and then after heating you will get elimination. So what you are going to get is this. Isn't it is known as cinemaldehyde, if I am right? Am I right? I'm just getting a blur vision of this. Is it known as cinemaldehyde? Trans cinemaldehyde? Because I have worked on this. I have worked on this in the lab, I guess. Trans cinemaldehyde, I used it. in my reaction, one of the reactions, right? So this is trans alkene, right? So that is why I think so. This is known as trans cinemaldehyde, if I remember correctly, right? No, no, no. This Kenso is not here, right? This Kenso is something different. This Kenso reaction is not this one. That one is simply Cannizzaro, right? Very nice. So this is trans cinemaldehyde. Very nice. Okay. So now let me ask you some difficult level question of which you will be able to answer only those whose direct product is very well aware in your mind, basically. Otherwise, if you try to solve this on the basis of mechanisms, trust me that you are ending terribly wrong, right? So suppose first of all we did this CH3MgBr and ether dry solvent, and second you used hydrolysis. What you get is this P, and then what you do is again you use let's say LiLH4, and when you use LiLH4, I don't think so that you can use LiLH4 further even. What you can use instead is CrO3H plus, you get this Q, and once you get this Q, there's some issue, I guess. There is some issue. Wait a minute. ठीक है. CrO3H plus, you get this, and then if you do something which is again very very important, you get R. Even I am not sure I have made the right question or not. I think so this is correct. If you use CH3MgBr, I am solving just alongside. Okay, so let's do this together. Treating CH3MgBr will get me that. Will give me this, and then followed by yes, you get yellow PPT. So what I am trying to do is, if I use CH3MgBr, what I will get is a ketone, right? Ultimately, not ketone right now. First, I will get this 2-degree alcohol, and when I this is basically P after hydrolysis, and when I oxidize it using strong agent like CrO3H plus, what I get is corresponding ketone, because 2-degree the oxidation of 2-degree alcohol leads to the ketone, right? And when I treat it with I2NaOH, the final product becomes the salt of benzoic acid. But since I have hydrolyzed it, I will get the acid directly, and you will get a CHI3 altogether, which will basically be the main source of identification of this reaction's completion, that is the precipitate formation. So this is haloform reaction, the last one. Got it? Now suppose you have this and you have you get something, so you have to tell optically active centers in R. Do it. Ashmit, CrO3H plus actually does not convert secondary alcohol to acid. If you use CrO3H plus and you have a primary alcohol, then you will get acid. But if it is a secondary or a secondary alcohol, then you will get ketone, right? And if it is a tertiary alcohol, you will get elimination product, right? Alkene. Ashmit, I got me. I hope that you got it. Bolo. Tell me how you're going to proceed in this reaction, basically. Nice. So are you guys confident in aldehyde, ketone, carboxylic acid and whatsoever chapters we have discussed in organic? Because here also we have tried utilizing the reactions from almost all of the chapters that we have discussed, right? Obviously, there are a lot more ways through which the question can be asked, but the main thing is that part by part, the reaction that they are going to ask in a bunch, every one of that individual reaction is very well studied by you, practiced by you, right? And we have been discussing these long forms of questions, series questions from a very long time, so I think so that you're now quite confident. Yes, Vaishali, just after this question I will tell you. Yeah. So what will be the product according to you after you do the hydrolysis and react it with the red phosphorus Br2? I guess you are very well aware about the fact that you will get a kind of a this product, or maybe you can say you get a this product which can be both above or below. So you get a chiral center, so you have one chiral center here. And what is the name of this reaction, the last one? HVZ reaction, right? After this is HVZ, remember, right? Now see beta, you were asking that how this thionyl chloride, suppose this not thionyl chloride, suppose this is acyl chloride, if you have CH3 CH3, right? CH3 or CD? Yes. So you have this CH3 MgBr, suppose, in dry solvent. So this acts as a nucleophile. It goes here, shifts this carbonyl's proton, no, not proton, the bond upside, making a O minus Cl and CH3. Now we very well know that Cl is a good leaving group. This O minus comes down and kicks this out, and what you get is ultimately a ketone, right? But this reaction does not stop here, right? Again, we know that if we treat this with another mole of CH3 MgBr, what we'll get is it will attack here, it will go up, again it will form a O minus CH3, another CH3. But since there is no leaving group right now to be kicked out, so it has only one option: to abstract proton from the environment and to ultimately be converted alcohol. So this is how I claimed that using Grignard reagent, since it is very reactive, will attack 2 times on acyl chloride, right? So I hope this is clear. So all right, guys, this was all about aldehyde, ketone and carboxylic acids, important reactions which we must understand, which we must know before jumping into the exam directly. Now, there are few important methods of aldehyde, ketone, carboxylic acid that are left, but why they are left, you know the answer, because we are going to cover those in the next chapter, that is amines, right? So in amines, we will cover all those left out reactions that basically you might not have studied in the lectures up to now. But once your amines is finished, I bet you, I guarantee that if you revise all these reactions again and again, if you practice similar questions again and again, then in exam, whatever question will be asked, you will solve those questions very fluently, very easily, without any hassle, right? So please keep on revising. We are just a step ahead, you know, before completing organic. So I guess this week is ours, because your physical will be most probably continued after this week, and we will try to finish the entire organic chemistry syllabus within this week, so that I could give you a final goodbye, and we will see you then just one day before exam, right? Venkat, it is something that depends upon you. If you're quite comfortable in recalling the reactions in whatever revision number, just stick to that. If you think so that if I revise one time it is quite good for me, it is quite okay for me, then you should decide the right amount of revision, Vaishali, that is great. You're going great. Okay, if you try improving like this, definitely you're going to get selected in both the exams, right? So okay guys,